Good afternoon.
But matter.
Shall we start? We have solved many problems of finding designing the shaft, comparison of power, comparison of strength, and other things. Let us go ahead and solve problems on series and parallel combination of shaft, step shaft, and something other related things, other types of problems. Okay, the problem statement is like this. A solid steel shaft is loaded as shown in figure. Let me draw the sketch. This is fixed here. This is fixed. Determine the diameter of the shaft. We should find the diameter of the shaft so that the shear stress will be limited to 60 MPa. It means to say that design based on strength criteria. Assume angle of twist to be limited to 4 degree, which is equal to 4 into pi by 180. You convert it into reading that tell me. Rigidity modulus G, which is equal to 83 into 10 power 3 Newton per mm square. Also draw the torsion diagram. The torque is like this. This is point A, this is point B, this is point C. Here a torque of 750 Newton meter is given. I will directly write 750 into 10 power 3 Newton mm. This must be your first step. Okay. This is 1200 Newton meter. I will write it into mm. Convert it into mm. 1200 into 10 power 3 Newton mm. This length is given as 2.5 meter. 2.5 meter. I will write it as 2500 mm. It's also 2500 mm on the right hand side. This is the problem statement. We need to design it based on strength and based on stiffness. When these types of problems are given, as usual, according to our sign convention, if this is the shaft, this is the assume that I'm taking a section in the shaft. I'm taking a section like this x1 xx. This is my section. Okay. if the if the torque acts in this fashion, if you curve your four fingers, there is forefinger, middle finger, ring finger, and the last finger in a direction of the torque. For example, this is torque t, then the arrow will be pointing like this, isn't it? If you curve your four fingers like this, this is your curve arrow will be pointing like this. I always take this positive sign convention. I will take a section and I will assume that the torque is acting in the that is the axis is away from the section. That is my convention. Also in this case, the torque in this case, if you bend your fingers like this is positive torque. This is a positive sign convention for torque T. Okay. Now how we will proceed? Let me tell you. First, I will take a section XX. Now I will take this section. This is C. I will take a section XX. This is section X. I will take a torque in such a way that that axis is like this. That you should remember. This is sections BC. The torque here is 1200 into 10 power 3, and this is I will write torque BC. Torque BC. According to our convention, what we did for axial members, same thing holds good here. Summation of torque is equal to 0. My convention is this is the length of the member. If this is the length of the member, This is the length of the member. If I curve my fingers along the length, okay, if I curve my fingers along the length, for example, if this is a shaft, this is the torque acting. This is the length of the member. This is the torque T. If I curve this finger in the direction of the torque, if my thumb points outward like this, if my thumb points outward, then the torque is positive. In other words, assume that counterclockwise direction along the length direction is positive. In this direction, this is counterclockwise torque, but it is difficult. I will always assume that if I bend my fingers in the direction of torque, if my torque points away from the cross section, this is my torque. If it points away from the cross section, my torque is positive. Now, this is acting, this torque is acting like this. If you bend your four fingers, if you bend your four fingers, let me switch on my video. Is it visible? If you if you bend your four fingers, these are the four fingers. If you bend your four fingers in this direction, in the direction of torque is like this. This is the shaft, this is the shaft. If you bend your four fingers in the direction of torque, four fingers in the direction of torque, your thumb gives the axis, thumb gives the axis. On the other side where I have taken a section, there is a reaction torque, don't worry about that. If you bend your four fingers in the direction of torque, if the thumb points outwards, then it is positive torque. Okay, that you should remember. Next, I assume that same convention. If I bend my four fingers in the direction of torque, my thumb, which was pointing away from this section, therefore my torque is positive. Therefore, 1200 into 10 power 3. This I always assume that, for example, if you take a body like this, if force is F is acting on the right hand side, there will be also a reaction force in the acting on the left hand side. Summation of force is equal to 0 in the sense plus F minus F is equal to 0 on the same lens 1200. If this, my convention is acting in this sense, if the thumb points in this sense, that is positive. Whereas when you take torque BC, it is pointing in this direction, Therefore, minus TBC is equal to 0, or TBC is equal to 1200 into 10 power 3 Newton mm. Next, go to the next section. This is where I have taken the section. There is this is point B, this is point C. There is a torque 1200 into 10 power 3. Also at point B, there is a torque 750 into 10 power 3. And this section, I will always assume my torque like pointing away from this, like TAB. Summation of torque is equal to 0. TBC, if I take 1200, it is positive, acting away from the cross section. Always I should take along the length direction. If the length direction, the torque is counterclockwise, it's positive. 1200 into 10 power 3. When you take this torque, when you take 750 into 10 power 3, when you take 750 into 10 power 3, this torque is acting like this. It is not acting like this. It is acting like this. Hence, it is a negative torque. Negative torque minus 750 into 10 power 3. This torque AB is also acting in the negative direction, minus TAB. Can you tell me what is TAB? TAB is equal to, what is TAB? 1200 minus 750 into 10 power 3. How much it is? 450 into 10 power 3. 450 into 10 power 3. He has asked us to represent the torque diagram. Let me go to the next slide. Torque is similar to axial flow diagram. This is a torque diagram. Point A, point B, point C. This is how is the torque acting. 1200 into 10 power 3. This is fixed. At point B, it's 750 into 10 power 3. 750 into 10 power 3. Same the 3 points here. A, B, C. In the region AB, what is the torque? In the region AB, 450 Newton mm. Let me write. Sorry, it is positive 450. Positive 450. 450 throughout. 450 into 10 power 3 Newton mm. In the region BC, in the region BC, it's 1200. Actually, you should write it according to some scale. 1200. This is 1200 into 10 power 3 Newton mm. This is for representation purpose. And then this point C, right somewhere, 1200 into 10 power 3. Okay. Now, now he has asked us to design. We have found the tasks. We know for designing according to based on strength criteria, based on strength criteria, I can write, first we'll write the equation T by J, which is equal to tau by R, which is equal to G theta by L, or T by tau is equal to J by R. See, as soon as write this equation, um, I can write. I need to design based on this one strength criteria. I can use T by tau is equal to J by R. Let us go ahead. But what I can tell you is, I can say tau is equal to T into R by J. Tau is equal to T into R by J. I know tau. I know he has asked to find what? Determine diameter of the shaft, and he has given T max. Tau he has given. So in order for designing it, I have to consider the maximum shear stress 1200 into 10 power 3. We will do it for both the cases and we'll see. Okay, let me take this expression itself. First I will take 450 TAB 4. I'll write like this: T by tau of AB is equal to J by R of AB. T by tau, T is in section AB 450 into 10 power 3. Tau in the section AB, it remains the same for both the section. 60, it's in MPa. It's a solid shaft. Pi d power 4 by J is equal to pi d power 4 by 32 by d by 2, which is equal to pi d cube by 16. Shall I write directly? Pi d cube by 16. Can you tell me d? Next, T by tau of T by tau of BC, which is equal to J by R of BC. BC tau T is 1200 into 10 power 3 by 60, which is equal to J is pi d cube by 16. Diameter is uniform diameter. Can you tell me D in both the cases? We are designing the shaft. We consider torque as 450 Newton meter and carb as 1200 Newton meter. Okay, we should design it. Whichever the maximum diameter we get, we should use it. Because if we design it for 450, if we get 50 mm, and if we design 50 mm, if we get here 150 mm, then it may not withstand that 1200 in Newton mm torque. Okay, we need to take the maximum dia. Tell me the diameter of the shaft. What is TAB? Sorry, what is D? D in first case 450 into 10 power 3 by 60 into pi d cube by 16. How much you are getting? How much you're getting? Dhruti, Mikala, Raghavendra, Akshay Pratap, Sugun, Sushil Kumawat. How much you're getting? Sugun. Dhruti, how much you're getting? Mikala, how much you're getting? How much you're getting? 415 to yes, 33.677 diameter, which is equal to 33.66 mm. In the second case, is it 46.7 46.701 mm? You check it out. Are you getting this? Are you getting this? The previous problems, what we did, it was a uniform. The shaft was uniform. It was fixed at one end, and the torque was applied at the other end. It was uniform. So T remains the same throughout all the cross section, throughout the entire length. But in this case, the torque is varying from section to section. Henceforth, I have taken two section torques, and we have founded the diameters are 33 and 46 mm. Okay, hope you have got this. Next, this is design based on strength. We cannot come to a conclusion design based on strength itself. We need to go ahead and look for design based on angle of twist, wrist twist. There is design based on rigidity. Okay. Now, when I say design based on rigidity, design based on rigidity. So, I can write if you consider a bar like this, if there is a force F, if there is a force F1, F2, F3. If I want to find a deformation here, if there is a force F4, what is the deformation dl total? Which is equal to dl1 section 1 dlab plus dlbc plus dlcd, right? You remember this. On the same lines, total twist, which is equal to summation of twist in AB plus summation of twist in BC. Okay, where ab in the sense theta a theta ab in the sense theta b minus theta a, theta bc in the sense theta, sorry, theta bc or cb, it has to be theta bc in the sense theta c minus theta a. Okay, theta b minus theta, if this is b, theta b minus a, theta c minus a. Okay, now theta a is 0. Okay, theta b plus theta c. Okay, theta b minus a, theta c minus theta a. Oh, but you remember this, when I say total deformation is sum of the deformation acting at each section. That is the final deformation which is going to happen at this end. For total final deformation which is going to happen at this end. What is the deformation at this end? The angle of twist at this end, angle of twist at this end, and the final the total angle of deformation is summation of angle of deformation but each section. Since we are assuming that is a pure torsion, pure torsion in the sense if I apply a torque, in this case when you take T of AB, T of AB 450 into 10 power 3 Newton meter throughout this length AB, it remains the same. When you take BC 1200 into 10 power 3 throughout this section BC, it remains the same. Hence, this angle of twist is summation of theta AB plus theta BC, assuming that pure torsion is happening at each section. Okay. Next, when I say theta, when I say theta, T by J, which is equal to tau by R, which is equal to G theta by L, or T by theta, which is equal to Gj by L. This is a reasoning based on rigidity. Or theta total, which is equal to G, theta total, which is equal to, let me write it as TL by Gj, which is equal to theta. TL by Gj is equal to theta. TL by Gj of AB plus TL by Gj of BC. T in AB is 450 into 10 power 3, 450 into 10 power 3 length is 2500, 2500 mm. G, rigidity modulus G, it's 83 into 10 power 3 into J plus 1200 into 10 power 3 into 2500 divided by G, 83 into 10 power 3 into J. Okay, 10 power 3, 10 power 3 will cancel. You tell me in terms of first J. Okay, theta T, how much you are getting in terms of J. Finally, J will, and he has given, theta T has given, right? Theta T he has given, it has 4 into pi by 180. How much you are getting, you tell me. This is theta, maximum angle of the fish, theta T. Can you tell me what is theta? How much? 4 pi by 180. How much is this?
0.06.
0.0698. Okay. This is 0.0698. Tell me this in terms of J. Take J common. 83, 2500 by 83 also can take common. 450 plus 1200 into 2500 by 83. How much? Is it 49.698 into 10 power 3? Are you getting this? 49.698 into 10 power 3 by J. Are you getting this? Dhruti, Mekhala, Raghavendra, others, are you getting this?
Yes, yes.
Are you getting this? Okay. J is equal to 49.698 into 10 power 3 by 0.0698, or J is equal to pi d power 4 by 32 is equal to 49.698 into 10 power 3 by 0.0698. Tell me what is D. How much? Is it 51.894? 51.894? How much you are getting? Sugun, how much you are getting? Sushil Kumar, Raghavendra, Mekhala, Ruti, how much you are getting? Okay, D, it's 51. Are you getting this answer? 51.894 mm. Are you getting this answer? Dhruti, are you getting this answer?
Yes, sir.
Right? What about others? Ravendra, Mekala, Mekala.
Yes, sir. Same, sir.
Same way you will
Yes,
take.
sir.
Why you will take so long? There is you don't know that option in calculator that is numerator by denominator are doing like that, or in brackets or typing and doing like that. How are you doing calculations?
Bracket, sir.
Hey, don't do that. That will take a lot of time and prompt errors. You will do a lot of mistakes there. So you're struggling there. See, do you know this? You know this, right? This you, I think most of you know this. Let me show you. This option, do you know? This option, numerator by denominator, are you doing like this? Let me type and tell you. 49.698 into 10 power 3 by 0.0698 into 32 into 32 volts into shift 5 raise for 1 by 4, that is 0.25. That's it. This option you should use, numerator by denominator. And for example, if you want 5 power, that is 5 power, use this option 5 power. 1 by 2 in the sense, once again use this 5 power 1 by 2, you can do that.
Sir, not clear, sir.
How can I show you? For example, 5 is the
Yes, sir.
red,
Now it's clear, sir.
5 is there. 5, I are seeing some value, 9 is there, let me write 9. 9 power, is it clear? 9 power 1 by 3 by 2 want to do. This, have you seen this? Power symbol has come. Have you seen this? Have you seen,
That we know, sir. How numerator by denominator?
that power by also you can do that. 3 by 2, 9 raised for 3 by 2. Then why you are taking so long? Okay. Next problem will go ahead. The problem statement is like this. Okay, I need to make the conclusion. Okay, last 10 minutes remaining. So now the diameters what we found was first diameter was a constant torque of 450,000 Newton mm, and the second diameter what we got was 46.701 mm, and the third torque diameter what we got was 51.894 mm. Which one is suitable? If you say for 33.66 mm, then it may fail due to when you apply a torque of 1200 into 10 per Newton mm. If you say 46.071 mm, then it may fail due to a angle of twist of 4 degrees. Therefore, the maximum diameter you should say you should choose the maximum. Therefore, the suitable diameter for this shaft is suitable diameter is D, which is equal to 51.894 mm. This you should choose. Okay. Next. Next problem. Shall I continue or shall I continue in the next class? Let me to finish it off. Okay. I will send you one more link within 2 minutes or 5 minutes. I will send you one more link. We'll complete this problem. Okay. Two problems. Tomorrow's class 2 problem that completes your torsion. Okay. The problem is like this. Determine the angle of twist between A and C for the brass shaft loaded as shown in figure. Okay. Angle of twist between A and C. Shaft is subjected to 400 into 10 power 3 Newton and torque here. This is point A. This is point B. This is point C. It is subjected to a torque 1200 Newton mm, 1200 into 10 power 3 Newton mm, and here 800 into 10 power 3 Newton mm. He has asked determine the angle of twist between A and C. Angle of twist between A and C for the brass shaft loaded shown in figure. Take rigidity modulus G is equal to 40 GPa, which is equal to 40 into 10 power 3 Newton per mm square. The shaft diameter D, which is equal to 40 mm. This is the given problem data. We need to find the angle of twist between A and C. Okay, this is the given problem. That is theta, theta total. If I say it is nothing but theta AC, which is nothing but theta AB plus theta BC. It is as good as holding here and applying a torque here. So theta S in the sense the torque throughout this length, the summation of torque in this section and this section. Theta AC is theta AB plus theta BC. Okay. Okay. Now in order to find theta, before finding theta, we need to find the torque and in each section. I will take the section here, XX. Anywhere you can take between B and C. This is a section C. This is the section part. Here 800 into 10 power 3. If this is the length direction, along the length direction, if you bend your fingers, if your thumb points in away from the section, this is the section, this is the section. If thumb points away from the section, then your torque is positive. Or you can assume that if you along the length direction, counterclockwise torques are positive. But this torque is clockwise, and I will always apply a torque acting away from the section. That is TBC. This section, this is like this. Okay, summation of torques is equal to 0. This torque is acting like this, minus 800 into 10 power 3 minus TBC is equal to 0, or TBC is equal to minus 800 into 10 power 3 Newton mm. Okay. Let us go to the next section. Next section, TAB. This is C. This is B. This is my section. The section length is 1000 mm, 1500 mm. C, this is 800. This is acting in the clockwise direction. This is acting in the counterclockwise direction. Hence, this is positive. 1210 for 3. I will take a torque which is acting away from the section, which is also in clockwise direction. This is torque BC. Therefore, it is negative. Summation of torques is equal to 0 minus T BC plus 1200 into 10 power 3 minus 800 into 10 power 3 is equal to 0 minus TBC plus 400 into 10 power 3 is equal to 0. TBC is equal to 400 into 10 power 3. In the region BC, there is a torque of 400 into 10 power 3 Newton mm. Sorry, this is not BC, this is AB. TAB. You should tell me, right? TAB, TAB, TAB. In the region TAB, there is a torque of, I have taken a section here, This is region TAB. Torque is 400 into 10 power 3 Newton mm. Okay, that is good. Torque T by J, which is equal to tau by R, which is equal to G theta by L, or T by theta is equal to Gj by L, or T into L, T into L by Gj, which is equal to theta. T into L by Gj is equal to theta. Theta total or theta AC, which is equal to theta AB, theta AB plus theta BC, theta AC, which is equal to TL by Gj of AB plus TL by Gj of BC. Torque in section AB, it's 400 into 10 power 3, 400 into 10 power 3. Section AB length is 1000 mm, 1000 mm. Rigidity modulus G, 40 into 10 power 3, 40 into 10 power 3. So this shaft has uniform cross section. Let me write it. Sorry, this shaft is given uniform cross section. Diameter D is 40 mm. Let me write it as J plus this TBC. TBC is minus 800 into 10 power 3, minus 800 into 10 power 3. Length is 1500 by G. G is 40 into 10 power 3 into J. Can you tell me in terms of J what is J? Also you can substitute. First you can also substitute, or let me write it as, okay, you tell me in terms of J first, or if for simplicity you can directly take pi d for 4 by 32. Let me write it here only, into pi into diameter of the shaft is 40 mm, pi d for 4, 32 into, which is equal to pi into 40 for 4, okay, into 32. Tell me this, what is theta AC or theta total? So you should do, only 1 minute remaining. I'll give you the answer, you cross check yourself. Theta total, which is equal to minus 0.0795 radian, or theta total or theta AC, which is equal to minus 4.5594 degree. It means to say that the torque is acting in the clockwise direction. It is clockwise torque, clockwise. At in this region, the angle of twist is in clockwise direction. Okay, angle of twist is in clockwise direction. You check it out. Still another 1 minute is remaining.